Now, again, this is Chemistry 3053, continuing with Chapter 11, and we'll look at the last three sections of Chapter 11. These are synthetic considerations. Remember the retrosynthetic analysis. We'll look at that just a little bit more, and we'll look at green chemistry and practical tips for increasing the proficiency of your synthesis. So, the retrosynthetic analysis, remember you are solving for the reaction in reverse. You look at the product and figure out what you need to synthesize, to make the product. So you're going backwards instead of looking at the reagents or the reactant and going forward. Sometimes it can take a bit of both, though. So you still need to ask the same two questions we just discussed in the last video. Is the carbon skeleton changing, and is the functional group changing or moving? So you analyze the structure of the reactant and product. You have to look at what functional groups you're dealing with. So here you have a triple bond. This is your target molecule. Okay, is there a change in the carbon skeleton? So you have a T-butyl group and a 2-carbon chain, T-butyl group and a 2-carbon chain. No, your carbon skeleton is not changing. You simply need to, you're starting out with an alcohol functionality, and then you're going to have to put a triple bond across here. So let's look at this target molecule and see what we figure out that we can do with that. Now, so we'll focus on this step first. What do you have? What do you know? Which ways do you know of that you might be able to make this alkyne? Okay, and you don't necessarily know that you're going to have 3 intermediates. You're given that here to make it a little bit easier for you. And so the alkyne can be installed on this carbon skeleton by elimination of HBr twice. Now, you don't know how to do this. You don't know how to do that one, but you do know how to make that. Okay? You haven't had any experience in making the other two. So you do know how to make that, so you can do this transformation since you know how to make the starting material there. So, your product, your target molecule, can be made from this dibromide. This is the one that you know how to make. And so here you have your next to last molecule, and you know how to do that. So you put the reagents in, and now this becomes the target molecule that you need to make. And so you have to figure out what ways do you have of making this target molecule. Well, you know that you can add bromine across a carbon-carbon double bond. And so here you have it. You can, if you have a double bond, you can add bromine across it. So this is your retrosynthetic analysis. This can be made from that. And so now you have this transformation you can put in front of the previous one. So now this becomes your target molecule. And this is going to be relatively easy. You know how to convert an alcohol into an alkene. We've seen that before. So the first thing that you need to do is make the alcohol a better leaving group, tosyl chloride and pyridine. Then use DBU or DBN and synthesize the alkene from that. And so now you have your total synthesis there. Here's the synthesis. Okay. Tosyl chloride makes that a better leaving group. Now you have a strong base. or the DBU or DBN, like you just saw in the previous slide, then bromination, then excess sodium amide, and then you add water. Now notice how all of these are stacked up on one arrow like that. I really doubt that they're saying that this is a one-pot reaction. I just doubt that, because you're going to have too many byproducts in here. So really, this would be one pot, that would be one pot, then another one, and then so these two would be together. So you're probably really going to have one arrow for these first two, an arrow for this one, and then one arrow for these last two. So I think that they're just trying to make it a little simpler for you and throw everything in together there. Whoops. Green chemistry refers to reactions that are more environmentally friendly, and it has 4 guiding principles: prevent the waste, use less hazardous substances, use safer solvents, and maximize the atom economy. In other words, you don't have a lot of byproducts generated. So here are 2 different reactions. Notice when they say poor atom economy, the atoms in red are all wasted. Poor atom economy. Here, this is just catalytic amount of acid, and that's not a huge concern. You can neutralize that. So this has a good atom economy. And moreover, notice this up here has mercury. There are huge concerns about disposal of mercury. It's very expensive. It has to be treated separately. It has to be put in a separate waste container. And so there's more concerns to this, using this, than just the atom economy. And a lot of textbooks don't even include this reaction anymore because there's such an aversion to using mercury reagents. To continue with green chemistry, use catalysts rather than stoichiometric reagents. Energy efficiency, you want to work with reactions that are performed at room temperature so that you don't have to use so much energy. And you want to try to use renewable feedstocks. These are just additional principles of green chemistry. Increasing your synthetic proficiency. So you need to keep in mind the reactions that alter the carbon skeleton, like we've said, and you can start keeping sort of a list of those, because it's going to be a short list where you're going to have only 4 reactions in this course that will enable you to increase the carbon skeleton. You've just seen 1. You're going to have 2 more in Chapter 12 and 1 more in Chapter 13. And I'm making a list for you, so you'll see them all at the end of Chapter 13. You can, this is an idea that the book has for studying synthesis problems. You create your own synthesis problems. Okay, design your own. I think it'd be a lot easier just to use some out of the back of the chapter, but this is a way that you can do it. You choose a reaction, write out the reagents, predict the structure of the molecule, repeat it a couple more times, make some reactions, draw some reactions going in the forward direction. This is not a retrosynthetic analysis, go in the forward direction, and then find a classmate who has done the same thing and exchange your problems, exchange your syntheses. But I think it would be a lot easier to just select some out of the back of the textbook chapter. But here, this is more on how to create a reaction synthesis sequence, a reaction sequence. So you deprotonate the alkyl proton and you create an anion there. You react that with an alkyl halide. You repeat the step a couple more times, so you put alkyl groups at each end, and then you hydrogenate that to create a cis double bond. And then you can swap this with a classmate and have them work yours and you work your classmates. There can be multiple correct answers also. So notice here you have, you're needing to oxidize this to put the alcohol functionality at the terminal carbon. You know that hydroboration oxidation does that. You also know that anti-Markovnikov addition will do that. So you have two different routes to solve this synthetic problem and create your target molecule. Now this is another one of the starburst diagrams where in which you see all the different reactions that it's possible for an alkene to undergo. This is a great way to study. You start with this starburst diagram where none of the reagents are drawn in. And then this is the exact same starburst diagram with all of the reagents drawn in. So what you can do is print this out, print that out, and then use this one to test yourself and fill these in and then compare your answers versus these answers. And so that is how this can help you learn all the different alkene reactions. And then here are some an alkyne starburst diagram where you've got a lot of different reactions that the alkyne can undergo. Here, none of the reagents are drawn in. And this is the exact same diagram. It might not look like it, but it's spread out a bit more to give space for all the reagents to be drawn in. And here you can test yourself by writing in the reagents. So you print this one out, try to fill in the reagents that would perform each one of these transformations. You have this one printed out also, and you compare your answers on the previous page versus these answers. It's a great way to test yourself. So that takes care of your syntheses, and this gives you a great way to review your reactions from chapters 8 and 9.